Substitution method for solving systems of equations. So systems of equations, we're solving for two variables by using two equations. So we can solve for two variables at once, but we need to have two equations in order to do that. And the substitution method will give us the same solutions as if we were solving by graphing. It's just done algebraically. So what does equal mean? So if 2 plus 3 equals 5, to be truly equal means we could substitute 2 plus 3 with 5. It's kind of like if there's like a retired math teacher, they could come in and they could substitute and teach my classes. They could come in and do the exact same thing I do, just like 5 here can come in and replace 2 plus 3, because in order to be equal means we could substitute it in without changing the value. So let's look at an example. We have y equals 3x minus 1 and 2x plus y equals 9. So if y truly equals 3x minus 1, then y could be replaced with 3x minus 1. So we're going to take that fact that if y is equal to 3x minus 1, we could replace y with 3x minus 1. So we're going to take this 3x minus 1 from the first equation, and we're going to replace y in the second equation with 3x minus 1. So we have a new equation. Now with instead of a y here, we have 3x minus 1. And what that's done is created an equation that just has a single variable. And by just having a single variable, we can solve for x. We can do 2x plus 3x is 5x, minus 1 equals 9, add 1 to each side, divide by 5, and I get x equals 2. So by substituting in that value, I had an equation with one variable, then I could solve for that variable. Now that I have x equals 2, I'm not done because I have two variables to solve for. In this case, we have an x and a y value. But I can take x equals 2 and go back to one of my original equations or an equivalent equation and substitute in 2 into one of these two equations and find out what y is. So let's use this top equation. It looks the easiest one to use, y equals 3x minus 1. We're going to take that y equals 3x minus 1, and we're going to replace this x with the number 2. So then I get 3 times 2, which is 6. 6 minus 1 is 5. And I have the ordered pair for my solution now. I have 2 comma 5. Now you do have to be careful. It's not always the order that you find the numbers in. It's always alphabetical. It's x comma y. In this case, 2, 5. So the solution of 2 works for x and 5 works for y. And if we'd graph these two equations, the ordered pair where they would cross would be at 2, 5. Let's look at a new example. We have 2x plus 3y equals 7, and y plus 1 equals x. So first thing we want is like to see if we have one of our equations solve for one variable, or one of the equations with a variable on one side by itself. And the second equation is solve for x. X is equal to y plus 1, meaning x could be replaced with y plus 1. So I'm going to take y plus 1 from that second equation. I'm going to substitute it into the first equation, the substitution method. We're substituting in y plus 1 in for x. So my new equation is just going to have y's in it. I have 2, and then where the x was, I put in the y plus 1, and then I have the rest of the equation. Then I can solve for y. I can do the distributive property. I can combine like terms, subtract 2 from each side, divide by 5, and I get y equals 1. Am I done? No, I have half the problem solved. I have y equals 1, but I need to go back and figure out what x is. I can pick from either of these two equations. Well, this bottom equation is super simple. I'm going to use that one. I'm going to use y plus 1 equals x, and if y is 1, I have this most difficult of all math problems. I have 1 plus 1 is x, or x is 2. So my ordered pair for my solution will be 2 comma 1. All right, so let's look at a harder problem. What can happen in some of the harder problems is, let's say maybe both the equations are not solved for x or y. Well, we can go through the steps of isolating x or isolating y in one of the two equations. Now, your work could be different depending on which one you pick, but I picked to do, let's solve the first equation. Let's solve this one for x. I could have solved this one for y, this one for x, this one for y. I just have to get one of these two equations with one of the variables isolated on one side or solved for one variable. So I'm going to take this 2x plus y equals 8. To solve for x, I'm going to subtract 4y from each side. And then I'm going to divide by 2. That gets x by itself. So if x equals negative 2y plus 4, then x can be replaced with negative 2y plus 4. So I can go to that other equation, this one I didn't rearrange, and replace this x value with this negative 2y plus 4 to come up with my new equation that just has one variable, it just has y. Then I can go ahead and solve for y. I can do distributive property, combine like terms, subtract 12 from each side, divide by negative 1, and I get y is negative 2. And now that I have y is negative 2, I can go back and figure out what x is. Well, not only can I use either of the two original equations, I can also use that one I rearranged and solve for x. And that one makes the math a little bit easier. So let's use this x equals negative 2y plus 4. Since y equals negative 2, we can now substitute it back in to any of our equivalent equations. So I'm going to put negative 2 in for y. Negative 2 times negative 2 is 4, plus 4 is 8. So my ordered pair that is a solution to the system of equation is 8 comma negative 2. An x of 8, a y of negative 2. And I could go back, I could take this point, I could put it in both equations, the original equations, I could prove that it works. I could also take both these equations and graph them on a coordinate plane and make sure they cross at 8, negative 2. Make sure they are truly the solution for both variables. All right, let's go through our summary of steps. What did we do in order to solve systems of equations by substitution? We solve one of the variables, one of the equations for one of its variables. So sometimes you're going to be given equations that are already solved for a variable, which is great, then you don't have to do step 1. But if either of the equations are not solved for the variable, you can rearrange the equation, solve for one of the variables. Step 2, substitute the expression from step 1 into the other equation and solve for the other variable. So once we have one of the equations solved for a variable, we can take that and substitute into the other equation to create our equation with a single variable. Then we can substitute the value from step 2 into the revised equation from step 1 and solve. And we can check our solutions to make sure they work in the original equations. And we always want to write our answers as ordered pair. And let's say we have variables that are not x and y. Say they're m and n or c and d. They're still just going to be alphabetical so that you can keep your variables straight that way. So systems of equations, there are other methods to solve. You should be familiar so far with graphing, solving to see if they cross at a point. If they cross at a single point, that's your solution. If they're parallel lines, you'd have no solution. Or if they coincide, they make the same line, they'd have an infinite amount of points in common. And then today we've solved algebraically with the substitution method to get the same solutions. And I hope that helps you guys working towards better understanding of systems of equations. Have a great day. OUT spells